In this video I'm going to solve a linear equation with Gauss Jordan method. So the question is saying use Gauss Jordan elimination method to find all the solutions of the following system of equations. So let's see how we can find this answer. Okay, here we go. First of all, I'm going to write this one in a matrix form, so everything will become easier. So the first equation says 1 5 1 2, and we have to be careful in this case. There's no x3, so that will become 0. So it's 1 5 0, and x4 is 1, x5 is 2, and answer is 1 right here. And the second one is 3, and x2 is 15, x3 is 1, and x4 is 5, and the last one is 3, and this is 5. And the third one 2, 10, and this one doesn't have x3, so it's x3 is 0, and x4 is 2, and xy is 4, and the answer is 2. Now in this case, so if they ask us to find in Gauss Jordan method, we have to bring the pattern that's whatever the number below is below the pivot is 0, and the number above should be pivot should be always 1, right? That's Gauss Jordan method. So since we have three equations, we have to bring it into 1 0 0 0 1 0 and 0 0 1. Let's see what happens if we do that. So first of all, I start from the bottom. So to make the bottom one 0, I have to multiply the first equation by -2 and add it with the third equation. Let's see. So I'm copying the same one, 1 5 0 1 2. This is 1, and the second one is 3 15 1 5 3 5, and the third equation I'm going to change it. I'm going to multiply the first equation by -2 e1 plus e3. So if I multiply and add, -2 plus 2 0, negative 2 times 5 is -10 plus 10 is 0, -2 0 0 0, and -2 times 1 plus 2 is -2 plus 2 is 0, and -2 times 2 is -4, -4 plus plus 4 is 0, and -2 times 1 is -2 plus 2 is 0. So the bottom all are 0. This tells us this equation has infinitely many solutions. So first we can just eliminate the bottom one and let's deal with the second equation. So first of all, let's see, 1 5 0 1 2 1. So in order to make this one 0, I had to multiply the first equation by -3 and add it to the third equation. So -3 e1 plus e2, this one, right? e2. So if I multiply the first equation by -3, it's going to be -3 plus 3 is going to be 0, and this one -3 times 5 is -15 plus 15 is equal to 0, and -3 times 0 is 0, 0 plus 1 is 1, and -3 times 1 is going to be -1, -3 plus 5 is going to be 2, and -3 times, -3 times 1 is -3 plus 5 is going to be 2, and -3 times 2 is -6, -6 plus 3 is going to be -6 plus 3 is going to be -3, and -3 times 1 is -3, -3 plus 5 is going to be 2. So we have two equations, and if you see this equation, 1 over 0, so first whatever the number below the pivot is 0, right? And in this case the pivot is third number and it's 1, that's what we want, and whatever the number above the pivot is 0, so that's all we want. So we have brought these two equations into Gauss Jordan method. Now what we have to do is we have to find the free variables. Free variables are whatever the what all the variables except p beta are free variables. So if you see x1 is a pivot because this one has leading coefficient, leading value. This one is leading, so this is pivot, and here is this one is pivot. But x2 is not leading, it's not a pivot, so this is a free variable. This is x2, and this is also free variable. This is not a pivot, right? So x4 is pivot. Now x4 is free variable and x5 is free variable. So we know x2, x4, x5 are free variables. We have to mention that first. And f, x, x5 are free variables. So whatever the answer we are getting is gonna be in terms of free variables. So let's solve for this one. Let's write the equation first. So first equation I can write it as x1 plus 5x2 and x3 is 0, x4 is 1, so x4 plus 2x5 equal to 1, and second equation is going to be x3 plus 2x4 minus 3x5 is equal to 2. So if you look at the first equation, except x1, x2, x4, x5, so x2, x4, x5, these are free variables. So I can directly find the x1 in terms of free variable just by uh, transforming these values to the other side of equal sign. Let's see what happens. X1 is going to be minus 1 minus 5x2 minus x4 minus 2x5. So this is my x1 values. To find the x3, x3 is going to be 2 minus 2x4, 2 minus 2x4 minus 3, it's gonna become plus 3x5. Now we had to we had this one has infinitely many solutions, so you can mention that if you want, and we can write this equation as 1 minus 5x2 minus x4 minus 2x5. This is my x1, and x2 is free variable, so I just put x2. We don't have to change it in any form. And x3 is not a free variable, so I have to write it in terms of free variable. So it's going to be 2 minus 2x4 plus 3x5, and x3 is written here, and x4 is a free variable, so I can just write it as x4, and x5 also a free variable, I can write it as x5. This is my final answer, and this is how we solve this question. I hope you guys enjoy this video. See you next time.